um, probability and binomial distribution again. So we've been given information. 10% of a country's population are left-handed. Oh, that's interesting. I wonder if that's true. The first thing they ask us about it is, what is the probability that 5 people in a group of 20 are left-handed? So this is very, very specific. They're asking for a specific success rate out of a certain number of trials. So our formula, and we'll call this question 1, and we'll deal with question 2 after. Question 1 deals with our probability distribution, which again was written as the number of trials or success rates with the probability of success and the probability of essentially a failure. Okay, so how do we define this information? What's the probability that 5 people, so in other words 5 people are left-handed, that's going to be our success rate, that's going to be our X value. Okay, that 5 people, and out of a group of 20, the group of 20 is referring to our number of trials, right? We're talking of drawing out of a group of 20 people. So because we're choosing from 20, that's the number of trials, and we want to know what's the probability of having exactly 5 of them being left-handed. So that's going to be the exact number of success rates. So that's all the information we need to essentially fill out this binomial distribution here. So P at the value of 5. So our N is 20 because there are 20 trials. We run it through a combination of 5 of them being correct. The probability we got from before. The probability was 10%. So as a decimal, that is 0.1. Okay. The power of X is 5. So that's the number of successes. Again, 5 people. That's the amount we're looking to be successful. Q is the probability of not being left-handed, which if 10% are left-handed, that must mean 90% are either right-handed or ambidextrous or don't have hands. Whatever the number is, it's 90%, okay? And then we do N minus X, so that's essentially the number of failures. So I'll write it in. It's 20 subtract 5, which is essentially 15, right? So we're looking for 15 people in that group being right-handed. So we'll actually go about solving this one here step by step. So we need a combination first. So our combination has 20 trials, and 5 of them are going to be, how many different ways can we choose 5 people? 15,504. Okay, so this is equal to 15,504. Okay. Then we're looking at a probability of 0.1 to the power of 5. Okay, and what that means is a decimal with 4 zeros followed by a 1. I know that's not the, it only writes it in that way. I'll have to fix that after. But what that means is 0.00001. 1, 2, 3, 4. 1, 2, 3, 4, 5. Yes, that's correct. So that's the probability of successes. And of failures here, we're looking at 0.9 to the power of 15. Okay, so 0.9 to the power of 15 equals 0.205, 2059, let's say, 0.2059 approximately. Okay, luckily on my calculator it saves those values so we can get really exact. So the next step is to just multiply these 3 numbers by each other, and that'll give us the exact probability we're looking for. So we're looking at this value multiplied by this value multiplied by this value is equal to 0.03. We'll round that up to 2. So 0.032, which as a percentage, because we would multiply by 100 to get our percentage, is 3.2%. So the probability out of a group of 20 people that 5 of them would be left-handed, there's a 3.2% chance that this would occur if you were randomly drawing the people. Okay. The second question asks, what is the expected number of left-handed people? Well, that's where we're using our expected value formula, which is, again, the number of trials times the probability. The number of trials in this case was 20. The probability was 10%. Okay, so 20 times 0.1 is 2. So when doing a trial like this, if you're pulling 20 people, you should expect about 2 of them to be left-handed in this trial.